Good evening, viewers. Welcome to MouShauk. Today we will discuss absolute zero, then absolute temperature, gas equation mainly. And I will give you two questions to solve, and I expect an answer from you in my next session. So before that, I will request you to please to subscribe my channel if you have not subscribed yet, and if you are a new viewer to my channel. And if you are liking the video, press the like button, share with your friends so that they can also be benefited from these videos. And do meditate before you start your day. So for meditation, let us concentrate on a point of light. And just maybe 1 minute, we will meditate and then we'll start with the discussion. So for meditation, concentrate on a point of light. Think of light is falling with you. The whole body is enlightened. Breathing, initiative, absolutely relaxed, meditation. Problems, all of these feeling, very joyful mood, feeling interesting work, and solving problems very easily. Feeling that there is something, I think there is someone who is being with you, who is supporting you. And at the end of the day, you are feeling that you're successful. So the company will also being with you and giving you so much support. Because start with that discussion. So we studied in our previous video about the Gauss's law and Charles' law. So in that we were talking about absolute zero, absolute Kelvin temperature. So according to Charles' law, V is equal to V0 273 plus T by 273. And we know from this graphical expression that volume at 0 degrees centigrade will be 30 ml and minus 273 degrees centigrade, the volume becomes 0. Okay, so let us express theoretically how it is done. So V0 is equal to, V is equal to V0 into T 273 plus T by 273. So V0 into 273 plus 2 minus 273 by 273. That means 273 minus 273 by 273 becomes 0. And so therefore V0 into 0 will be equal to 0. The volume of a gas at minus 273 degrees centigrade is 0. According to Lord Kelvin, if temperature of an enclosed gas at 0 degrees centigrade is lowered to minus 273 degrees centigrade, the volume becomes 0. But practically, it is not possible. This is theoretically, it can be represented, calculated that volume becomes 0. But practically, it is not possible. Because as a gas is one state of matter, it must have some definite mass and volume. It cannot be, it cannot happen in that way that it will be the volume becomes 0. Okay, so the temperature at minus 273 degrees centigrade is known as absolute zero. All gases will liquefy or solidify before reaching this temperature. Before reaching this absolute zero or minus 273 degrees centigrade, all gases will either liquefy or solidify. Theoretically, this is the lowest temperature that a gas can reach. but practically it is not possible. At this temperature, all the molecules they see, they do not have any motion. Okay, all the molecular motion that ceases. Practically, this temperature cannot be attained. Now, absolute or the Kelvin scale of temperature. Okay, we take 1 Celsius thermometer and 1 Kelvin thermometer. Okay? So we mark the upper fixed point and the lower fixed point in the Celsius thermometer and compare with the Kelvin thermometer. Okay, so we know the upper fixed point of Celsius thermometer, that is centigrade thermometer, is 100 degrees Celsius, and lower fixed point is 0 degrees centigrade or 0 degrees Celsius. Okay, so upper fixed point is known as steam point, and lower fixed point is known as ice point. Okay, now this 0 degrees centigrade or 0 degrees Celsius is 273 Kelvin. Okay, and Kelvin is 273 Kelvin, and upper fixed point is 100 degrees centigrade, that is 100 Kelvin, and that will be 373 Kelvin or 100 degrees centigrade, that is 373 Kelvin. Okay, 100 marks will be 100 markings will be there between the two fixed points, like that in the Celsius scale. The temperature scale with its 0 at minus 273 degree to 273.15 degrees centigrade, and whose each degree is equal to 1 degree on the Celsius scale. Okay, the 0 of the 0 at minus 273.15 degrees Celsius. 273 minus 273.15 degrees Celsius, 15 point of the centigrade scale, that will be equal to 0 of 1 scale. So what is that scale I'm telling you? Whose each degree will be equal to 1 degree Celsius of the Celsius scale. 1 degree of the Celsius scale will be equal to 1 degree of that new scale. That scale, new scale, is known as Kelvin scale or absolute scale temperature, whose 0 mark is equal to minus 273.15 degrees centigrade. 0 of the Kelvin scale is equal to minus 273.15 degrees centigrade, and 1 degree of that Kelvin scale is equal to 1 degree of the Celsius scale. Clear? That is that type of thermometer or that type of scale is known as Kelvin or absolute scale. Okay. Now, why do we need to convert the temperature from Celsius scale to Kelvin scale? Why? Because there's the need of conversion is that as Kelvin scale is an absolute scale temperature, so directly related to kinetic energy and work. Kelvin scale is an absolute scale of temperature. It is directly related to kinetic energy and work. So it can, when conversion is very easy, that is, we can actually know how much temperature is increased and what will be its kinetic energy and what will be its directly relation with it. The conversion of Kelvin to some other scale is not required. Temperature conversion is not required. As volume and pressure vary directly with absolute temperature. Okay, so volume and pressure, they vary directly with the absolute temperature. That's why this conversion of Celsius scale to Kelvin scale is needed. Okay, otherwise we have to convert from Celsius to Kelvin again. If it is in Celsius scale, we have to convert to Kelvin scale, and then we will be able to convert. We will able to relate with the volume and the pressure, because volume and pressure will vary directly with the absolute temperature, not with the Celsius scale temperature. Absolute temperature means Kelvin scale temperature. Okay. And another advantage, real advantage, is that it makes its application and use of the gas laws very simple. The Kelvin scale, it makes the application and the use of the gas laws very simple, and all values of the Kelvin scale are in positive. They are not in the negative senses, negative markings. Okay, they are all in positive. That's why conversion is much easier. Okay, that's why this need is required. Now, how do we convert this Celsius scale to Kelvin? We add 273 to the Celsius scale reading. Okay, then we can get the Kelvin scale reading. For example, 0 degree centigrade is 0 plus 273, then it is 273 Kelvin. Okay, 20 degrees centigrade is 20 plus 273, that is 290 Kelvin. Then 27 degrees centigrade, 27 plus 273, then 300 Kelvin. And when minus 273 degrees centigrade is minus 273 plus 273, then it is 0 Kelvin. Vice versa, conversely, when we need to convert Kelvin to Celsius, we subtract minus 273 from Kelvin reading and we get the Celsius. Okay. So this 0 degree centigrade is the ice point or the fixed point of water, fixed freezing point of water. That is 273 Kelvin. That is 273 minus 273. That will be equal to 0 degree centigrade. And if it is 0 Kelvin, then 0 minus 273, that is 27 degree Celsius. Then 13 Kelvin is 13 minus 273, that is minus 260 degrees centigrade. Or 373 Kelvin, that is 373 minus 273, that is 100 degree Celsius, that is the boiling point of the steam point of. Now, from this conversion, you must have noted that Kelvin scale reading does not show any degree sign. Like in Celsius, we write 0 degree centigrade, 20 degree centigrade, 27 degree centigrade. We tell also degree centigrade. Okay. But in Kelvin, we don't mention this degree. Why? Because it is an absolute temperature. So no degree sign is required. Okay. Size of 1 degree of Kelvin is size of 1 degree of Celsius. And we know what is the real advantage of the Kelvin scale. Why do we need to convert the Celsius scale into Kelvin scale before working on these? I mean, to find out this process of conversions. Okay. Now the gas, we come to the gas equation. Here in this gas equation, we need to know the relationship between pressure, volume, and temperature. Pressure and volume, we knew the relationship from Boyle's law. Volume and temperature, we know the relationship from Charles' law. When we are combining these two, Boyle's law and Charles' law, we get the gas equation. Okay. So according to Boyle's law, we know volume is directly proportional to pressure, and according to Charles' law, volume is inversely proportional to pressure is Boyle's law, and Charles' law volume is directly proportional to temperature. So combining both, we get volume is inversely proportional to 1 by P. Inversely proportional to pressure and directly proportional to temperature. That is P is equal to T by P into constant. Or you can say PV by T is equal to constant. The volume of a given mass of a gas changes from V1 to V2, pressure from P1 to P2, temperature from P1 to T2, then P1 V1 by T1 is equal to P2 V2 by T2, and this is the gas equation. Now, what is the importance of this gas equation? Why do we need to know the gas equation? Again, it allows us to investigate the relationship between non-constant characteristics of an ideal gas. Okay, of an ideal gas, we know how the temperature, is related to how the temperature and pressure and volume is related to one another. These are the constant, non-constant characteristics, and how they are related to energy. These are used for calculating the changes in the gas volume when both pressure and temperature change. When temperature and pressure changes, what is the how much the volume of the gas changes? That is also can be calculated by this gas equation. Now, ideal gas. Ideal gas has a standard temperature and pressure. Okay. Ideal gas is the gas which has a standard temperature and pressure. Okay. So what is the standard temperature and pressure, or you can say STP? Okay. So as the volume of a gas changes remarkably with change of temperature and pressure, it is necessary to change the standard, to change its in the change in temperature, pressure, it is necessary to choose the standard values of temperature and pressure to which the volume can be referred to. Gas volume can be referred to. The standard temperature is 0 degrees centigrade, or you can say 273 Kelvin. Standard pressure is 760 millimeter Hg, or 776 centimeter Hg, or 1 atmospheric pressure. As any change in the pressure and temperature likely change the volume of a gas, therefore it is needed to specify both the pressure and the temperature during the expression of a specific volume of a gas. Okay, we know if there is any change in pressure or temperature or both, then there will be a change in the volume. So we need to mention when we are expressing a specific volume of gas, we need to mention the rather specify the what is the pressure and what is the temperature during the specified volume of a gas. What is the specified volume of a gas is there, then what will be its temperature and the pressure, that should be mentioned. With the increase in pressure on the volume of a gas, enclosed gas, its volume decreases, but the increase in temperature, volume increases. Okay, so with the increase in pressure, the volume of an enclosed gas and the volume of the enclosed. Okay, on the volume of an enclosed gas. In enclosed gas, there is some certain volume is there of gas is there. When we increase the pressure on that volume, the volume will decrease. But if the volume decreases, the pressure, sorry, if the pressure is increased, volume will decrease. But with the increase in temperature, the volume will increase. So as volume, pressure is inversely related to volume. So pressure if increased, volume will decrease. But as temperature is directly related to volume, so if temperature is increased, volume will increase. Okay. To keep the volume constant, an equilibrium is kept between an increase in pressure and increase in temperature. Equilibrium has to be mentioned. If it is pressure is increased, okay, so temperature will be what? Volume is inversely proportional to temperature, and volume is directly proportional to, volume is inversely proportional to pressure and volume is directly proportional to temperature. Okay, so what will happen? Volume has to be constant. If we need to keep the volume constant, the pressure and temperature, that has to be increased in equilibrium position. Okay, balancing, we have to increase the temperature and the pressure. Okay? The effect of moisture on pressure. What happens if there is moisture in the gas? What will happen on the pressure? Some gases like nitrogen and hydrogen, they are sparingly or insoluble in water, and so they are collected over water. That is collected by downward displacement of water. And when they are collected over water, they will contain some moisture, rather water vapor it will have. So what will happen? Total pressure will be the partial pressure of the dry gas and also the pressure of the water vapor. So partial pressure will be there due to the water vapor. That will be also there. Okay. So that will be the total pressure of the moisture. And this partial pressure is known as aqueous tension. So what is this partial pressure? It is exerted by the gas if it alone is filled the containing vessel at the same temperature and pressure. in the same temperature and pressure if it is filled alone inside a container. Okay, that is known as partial pressure of the dry gas. And the pressure of the water vapor is also added to it. Okay, so pressure total will be P gas, that is dry gas, and then the water vapor, pressure of the water vapor. And P gas will be P total minus P water vapor. So actual pressure will be total pressure minus aqueous tension. Aqueous tension is the partial pressure. Total pressure minus partial pressure. Okay, so this will be the actual pressure. Okay, so this is the end of the chapter. I'll give you 2 questions to solve it. And in my next video, whatever chapter I study with, I'll start with, I will discuss with you this the answers of this. But before that, I expect also some answers from you all. Please do write in the comment box. Solve it and write in the comment box, or you can also write in my email ID, that is kasturi74@gmail.com. So the volume of a certain gas at constant temperature was found to be 1200 centimeter cube. When the pressure is 1000 millimeter of Hg, if the pressure is decreased by 30%, find the new volume. 30% of what? 30% of its original pressure. Okay, so what will be its new volume? A gas at, the second question is, a gas at minus 20 degrees centigrade occupies the volume of 140 ml. Okay, calculate the temperature at which the volume of the gas becomes 65 ml. Pressure remains constant. So please do reply. Okay, and go through the chapter. If you have any doubt, please write in the comment box. If you are a new viewer to my channel, please do subscribe to get the notification of my next video. Okay, and please maintain a chart so that you can have a track of how you are progressing, and do meditate before you start your day. So thank you for joining, and have a good day.